Good morning, students. Okay, today's bell ringer. We're talking about Derek. He's trying to save money for a down payment on a used car. And his parents have said that in an effort to help him put aside money, they'll pay him 10% interest on the money he accumulates every month. At the moment, he only has $200. Now, with only the parents' 10% interest payments, how long do you think it will take Derek to save at least $2,000 for the down payment? And then what kind of function would best model the savings plan suggested by the parents? So let's think about this for a second. He has $200, and after a month, his parents are going to pay him 10% interest on that. 10% of $200 is $20. So we add that to $200, and after 1 month, he'll have $220. After another month, we'll get 10% on the $220, and that'll add $22. So he'll have $242, and so on, etc. And we'll discover the answer here a little bit further along, but you'll see why that takes a very long time. Now, what kind of function do you think would model that? Well, I think you could probably describe it in both a recursive or an explicit function, and we'll look at both. So let's move on. All right, good things. I was able to encapsulate my my sync bar with the pickets. I'd show you a picture, but right now I'm videotaping my thing. Maybe one day I'll show you guys a picture of what it looks like. Looks pretty cool. But yeah, that's my good thing. Be sure to share anything that might be good for you. I'd love to share with the rest of your class mates what's going on in your lives. All right, so let's explore this in a little more detail. He's trying to save the money. It's going to pay him 10% every month on the money he accumulates, and he only has $200. If he doesn't add any money to the savings, we're going to write a recursive rule, an explicit function that models the money that Derek will accumulate with only the addition of the interest in his parents' pay. So if N is the variable that is the number of months, and D is the variable used for the dollar saved, the recursive rule model is D subscript N plus 1. That means the next value of dollars after a month equals N subscript N, which means the dollar amount that was in there already times 1.1, where the initial value of dollars, D subscript 0, is 200. And N moves increases by 1 every month. So 0 month is when he first deposits the money. The first month is when he gets his first interest. Second month, N equals 2, and so on. Now, the explicit or function rule model is D equals 200 times 1.1 raised to the N power. And N also increases from 0 to 1 and sequentially by 1. So let's move on. Okay, so let's use the recursive processes of the calculator to show how this works for the calculator. So let's go here, there. We're going to put 200 and then enter. So I'm going to use my calculator, 200 and then enter. So I have 200. Then the second step is to multiply times 1.1. So times, notice it throws whatever the last answer is, 200, and we're going to do whatever that function is, which is times, and we're going to multiply it by 1.1 and hit enter. Now, the answer to that, 200 times 1.1 is 220. If I hit enter again, it does the same exact function, except it uses the last answer. And if I want to continue doing that, it'll use the last answer every time. So that's 0, 1, 2, 3. I'm going to keep track of it until I get to 2,000. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 months, and we're still only at $1,000. So we'll keep going, 18, 19, 20, 21, I don't even know where I'm at, 22, 23, 24, 25 months. So a little after 24 months, he's going to have $2,000. So with the interest paid by his parents, it will take Derek just over 2 years to have that $2,000. Okay, so that's what it says in my answer. Let's see this. Derek, in order to speed up time, needed to save $2,000. He decides to take on some jobs in the community. If he commits to adding $50 per month to his savings, starting with the initial deposit from his parents, that $200, he's only going to get the 10% plus $50. So after 1 month, he has the $200 he starts with times 1.1, which means he's adding the 10% his parents give him, plus the $50 that he puts him to 270. And then we'll do that again. 200 times 1.1 plus 50 times 1.1 plus 50. That puts us at 347. And we follow that process again for the third month. And that gives us 431.70. We multiply that 431.7 the previous month times 1.1 plus 50 gives us 524.87. 524.87 times 1.1 plus 50, 627.36. We do it again, and we follow this process for a while. How much time do you think it'll take him to get to $2,000? Went a little too fast there. We want to put a scatter plot of these values into our calculator. So let's do that real quick. Okay, so stat, enter, and I want to put the months in column L1. So let's see, 0, 1, 2, it doesn't like my enter. Let's see. There we go. Oh, I don't know if you noticed this, but it's not registering all my numbers. There we go. Months 0 through 8, and then we'll put the amount of money in for each corresponding month. So the initial value is 200, then 270 the first month, 347 for the third month, 431.70 for the third month. Sorry, that was the second month, 347. 524.87 for the fifth month, 627.36, 740.09, 864.1, and 1,051 for the 8th month. Okay, so we have all 9 values from the 0th month to the 8th month, and we want to enter y equals, and we'll put the equation in there for our initial one. So let's look what that looks like. Y equals, and I already have it in there, 200 times 1.1 raised to the x power. And then we're going to hit zoom on the number 9, which is zoom stat. What that means is it's going to zoom the picture of all the information you've put in, the data values you put in the stat edits. So 9, and as you can see, that y equals 200 times 1.1 of the x, it grows rather slowly when you compare it to when Derek puts the extra $50 every month. That extra $50 seems to help a lot. Still grows in an exponential fashion, but it's a little different from exponential. So let's continue on. Obviously, you just saw the picture on my TA84 calculator. There it is again. Adding $50 per month greatly affects the overall time needed to save $2,000. So how long will it take him to save $2,000 for the down payment if he adds that $50 every month? The recursive rule in this situation says to multiply the prior answer by 1.1 and add 50. If you use this routine, it will take Derek only 14 months to save the money for the down payment. Let's see if this is true. That should be easy to do. We'll start with 200, and we'll hit enter. We'll multiply times 1.1 plus 50. And we'll do this process every time. Look, all I have to do is use the process. That is 8 months, 9, 10, 11, 12, 13, 14 months, just like it said. So, look at that. I misspelled that word. So, 14 months to save that money. And let's move on. How can you write a recursive routine for this situation? How about an explicit rule? Let's explain the reasoning when we write these rules and compare the responses. So the recursive rule described in this situation, $50 is added to the previous amount, and that sum is multiplied by 110.5. So the previous amount is 1.1 multiplied by 1.1, and then we add 50. And the new amount is that value, where the initial amount is $200 and n is the months as we move on, starting in 1 and 2 and then 3. Now, the function rule is not obvious in this case. You can write this series to describe the situation. D subscript n plus 1, the next value, equals 200 times 1.1 raised to the n plus 50 times 1.1 raised to the n minus 1 plus 50 times 1.1 raised to the n minus 2, and so on. But that process is not actually a function rule. In this case, the recursive rule is simple, and it is the most useful. If you change that amount of money that he adds to his savings each month to $100, how would that affect the time it takes to save the $2,000? And how much does he have to add to the savings each month to have enough money for the $2,000 down payment on his car in just 6 months? And we'll have to explain how we got that. So if you add $100 of savings each month using the calculator, we can find that it takes Derek only 10 months to save the $10,000. But using a table of values supports this conclusion. All we have to do is use a calculator and show it. And after testing several amounts greater than $100, it seems that Derek will need to save $200 per month to have $2,000 in 6 months. So if he starts with $200 and he puts $200 every month for 6 months, that's $1,200 plus $200, $1,400. He'll make $600 in the process and have the $2,000. All right, I'm going to launch you with this. Saving money is not difficult. Anyone can do it. The really hard part is the determination and the self-control that is required to do it. Now, after 50 years of attempting to save money, I found it is very easy to do. But keeping that money you've saved is as difficult as wearing pants made of raw steak in a lion's den. That is absolutely the truth. However, that doesn't stop you from your responsibilities. Go into the Google Classroom and finish the assignment by the same name, Comparing Models, SAS 4, Unit 4. In the meantime, be blessed and be a blessing.